Welcome everybody. This video is over absolute value equations. So today we're going to solve equations that have the absolute value bars. It's very important to note that these have two answers, and that's because the graph has a positive side and a negative side. So here is the parent function, the absolute value of x. It can also be written as what we call a piecewise function because the graph is broken into pieces. Again, we have a negative side of the graph. So where x is less than 0, it's negative. That's our negative slope. And then if you look, we start to turn here at the vertex and it becomes a positive slope. So that is where it's greater than 0. What's really important is that's why we get two answers. We can use this y value with this x here and this x here. So what we're going to do is make sure that we first isolate the absolute value bars, because sometimes you can have something added or subtracted, and sometimes we can have something multiplied. Then we're going to split the equation and we're going to solve. And I'll show you what this means. We're going to split it one positive answer and one negative answer. We're going to jump right in. Sorry about that. So the absolute value of 2x plus 5 is going to be equal to 2. These bars are not ones. I get that question a lot. They're absolute values. Because there's only absolute value bars over here, there's nothing after or before, this is called isolated. So it is isolated on the left-hand side. So we can skip to step number 2 is where we split. We're going to copy the original equation, 2x plus 5 equals 2, on one side. And then the other side, because we don't know what's happening with the x, it could also equal negative 2. So we split our equation and we have one positive answer and one negative answer. And then from here, it's just a two-step equation. So we're going to subtract 5, and I'm going to solve them both. Wow, that is the longest bell ever. Sorry. I'm going to solve them both at the same time. You can do the left and the right. It doesn't matter. So subtracting 5, that gives me 2x equals negative 3 on this side, and over here 2x equals negative 7. And then to undo this multiplication, we're going to divide by 2, giving us x equals negative 3/2 and x equals negative 7 over 2. Now we want to write this as a solution set in set notation. What that means is I need a brace, the smallest number, the biggest number, and then close that out. So that's set notation. This is the answer right here. Okay, let's try another one. This time I have 3x minus 5, absolute value, is equal to 4. If you think you got this, you can skip over this part and move to the harder problems, or try this problem on your own, pause me, and then see what happens. See if you get it right. Okay, so our absolute value is isolated. That's going to skip step 1 for us and straight to step 2 where we split the absolute value. So 3x minus 5 equals 4, and 3x minus 5 equals negative 4. Notice I did not change anything inside the absolute value bars. You'll want to. Don't. Okay, add 5 to both sides. And continue to solve for x. So that is 3x equals 9, and 3x equals 1. Divide by 3. Okay, and write your answer in set notation. So I got 1/3 and 3. Ooh, there we go. Don't forget to box your answers for me so I can find them. Or highlight them, whatever makes you happy. I just need to be able to locate them. Okay. I'm going to fit one more on this page just because I want to make a point. So we're not going to need a lot of space because this is a special case here. I have 1 minus 2x in the absolute value bars, and then it's going to be equal to -3. If I have a case where the left side is isolated and the right side is already negative, there is no solution to this problem. We can't have a negative starting with our absolute value. So you don't even have to do any math. If this side is negative and this side is already isolated, your answer is no solution. Now be careful with that. You'll want to see a negative number and then immediately say no solution. But sometimes the left side isn't isolated. So let me show you what I'm talking about. Sorry. Let's say that we had absolute value of 3x minus 2 minus 5 equals to -2. Okay, right here we cannot stop and say no solution. Because the left side's not isolated, I have the bars and then I have a -5. So the first thing I have to do is add 5 to both sides, keeping my equation balanced, but also undoing this 5 right here. So a -5 plus a 5 is 0, which leaves this side as absolute value of 3x minus 2, and then over here, this has become positive. So we can keep working this problem. We don't have to say no solution. So I'm going to split, now that we're isolated, 3x minus 2 equals 3, and 3x minus 2 equals -3. Solve your two steps equations by adding 2 to both sides, and then we're going to divide by 3 because that's the coefficient of our variable. Okay, so these cancel. Well, they don't really cancel, they become 1, but that's okay. We have x equals 5/3 and x equals -1/3. We're going to list them from least to greatest and put it in our squiggly braces here. Okay, not bad. I want to do a couple more examples. Yeah. If you think you got it, you can skip to where I do 2 pairs, 1 on each side. But I want to throw some fractions in and some division just to make sure you got it. So if you need to, keep watching with me. I'm going to go a little bit quicker here. So we have 5 times 3 minus 3x minus 2 is equal to 13. Okay, absolute value bars are here. Again, not ones. We have to undo this subtraction first. So we're going to use the addition property and add 2 to both sides. So then we have 5 times 3 minus 3x, absolute value, is equal to 15. And then we're still not isolated. We have an implied multiplication right here. When the number is touching the absolute value bars, we need to divide by that number so that it becomes 1. Notice that I didn't divide anything inside the absolute value bars. The sole purpose of this move is to eliminate this 5 out front. So using the division property, I have to do it on both sides. That leaves me with 3 minus 3x is equal to 3. Okay. Now I'm going to solve this one. 3 minus 3x equals 3. 3 minus 3x equals negative 3. Now, don't freak out. It's okay. Don't lose this negative either. Negative 3x equals 0. That is okay. Oops, you can't even see me. Negative 3x equals 0. 0 is a number. That's fine. The only time that you would have to stress out about this happening is if we lost all of our x's. If I have something like one number equals another number and it's not true, this side alone would be no solution. So that's if I lose all my x's. But I have an x here still, so I can still divide out this negative 3. And 0 divided by negative 3 is a possible solution. We just have that x is 0. So that's fine. If you had 3 equals 0, you just put no solution on that side and then solve this side over here. So notice that I'm moving this 3 first, even though it's in front of the variable. That's okay. Just undoing that addition. Divide by negative 3. Okay, so those are our two answers, 0 and 2. Zero is a valid answer. So if I happen to have fractions, I'm going to set this one up. I'm not going to solve it, but you know what? Let's just do it. If you don't need me, just skip me. Move to the next problem. Oops, I started solving it already. Okay, so 3/4 x minus 6 divided by 5 is equal to 45 over 5. I'm going to start this problem off by multiplying by that 5. That's why I put it here. Oops, just a second. My camera does that every once in a while. When I multiply by 5, that leaves 3/4 x minus 6 is equal to 45. It cancels out those denominators. And then I can work with this problem here. I wanted to do it because it had a fraction on it. Okay, so when you start to solve, remember that to get rid of this fraction, oh goodness, I'm rushing now, I'm sorry about that. You can divide by the fraction and then use the keep change flip, or you can multiply by the reciprocal and it'll do the same thing for you. So I'm going to show you the division. When you divide this, these cancel out, leaving x on this side. And then over here, you keep the 51, change the division sign to a multiplication, and flip over the fraction. That's how you deal with dividing by a fraction. So then you can do 51 times 4 divided by 3 to get 68 on this side. And then the same thing over here. And when you figure out this one, you should get negative 52. So if you want to work this side, see if you can do the keep change flip, you should get negative 52. To give us negative 52 and 68 for this one. So you can get rid of the fractions by multiplying by the fraction, or dividing by the fraction and then using keep change flip, which becomes multiplying times the reciprocal. Okay, now we're getting long here in the video, so I need to make sure that I cover absolute values on both sides of the equation. So if you're looking for absolute values on both sides of the equation, you found it. It is very similar to one absolute value. You should already have them isolated. I think I set them all up isolated. We're going to still split our page. We're going to write the original problem on the left. I'm not going to change anything. I'm just dropping the absolute values. On the right-hand side, x minus 2 stays the same. And then before, I would change this to a negative. We're going to do the same thing. We're going to do a negative and then a parentheses so that I don't remember to make the entire side negative. Okay. This side, solve like normal. Going to add 2x to both sides to give me 3x minus 2 equals 1. Add 2. 3x equals 3. Divide by 3. X equals 1. On this side, on the right-hand side, I'm going to multiply and distribute this negative 1 out first. So we have x minus 2 equals negative 1 plus 2x. And then you can start to solve. I'm going to move my x to the right just because. It gives me negative 2 equals negative 1 plus x. Add 1. Negative 1 equals x. So I have two answers, positive and negative 1. Put them in order from least to greatest and put them in set notation. Okay, so the only difference in this is that the whole left side becomes negative. So do you have to do this negative parentheses? No, you could just make everything negative, but I'm going to bet that you're going to forget, so I would do the negative parentheses. If you got it, you got it. You can move on. I'm going to do one more problem, and then I'll close out the video. So we have 2x minus 9, absolute value, is equal to 8 minus 3x, absolute value. Oh, I did that all in one color. We're going to split. Write the original, 2x minus 9 equals 8 minus 3x. Just drop the absolute value. On the other side, 2x minus 9 equals negative, parentheses, 8 minus 3x. And then just solve. So I'm going to add 3x. To give us 5x minus 9 equals 8. Add 8. Add 9. Divide by 5. And we got this beautiful fraction, x equals 17 over 5. You can leave it like that. You can make it a decimal. It doesn't matter to me. Either way is fine. Okay, over here, 2x minus 9, and then we have it equal to, distributing the negative 1, we have negative 8, and then negative 1 times negative 3 is positive 3x. Okay, I'm going to subtract the 2x. I'm just trying to keep it positive. You can do this any way that you want. If you are fine dealing with the negatives, that's okay too. Okay, add 8 gives us negative 1 equals x. So again, two answers, negative 1 and 17/5. Okay, so now you can complete the front of homework 3. Be careful on number 7. If you have any questions, reach out to me.